Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fazli bin Muhammadiyah. I'm a third year student of Bachelor degree in Civil Engineering in Technology in Construction from Faculty of Engineering Technology. Today I will present about my final year project proposal entitled Utilization of Palm Oil Fiber POF as Thermal Insulated Roof Ceiling Panel. As you can see in my slide, my supervisor is Technologist Muhammad Lutfi bin Ahmad Jeni, while my co-supervisor is Technician Helmi bin Kosnen. For the introduction, nowadays, the world are facing a great crisis, which is global warming. It is a serious problem to all humanity. The counterpart of the problem is another issue, which is the increases in energy consumption. Based on a study in 2016 by Rahman, about 82% of energy consumption just in Peninsular Malaysia is from domestic use. This shows that usage of cooling home appliances such as air conditioner and fans are high. To overcome this problem, the installation of thermal insulating panel can help. The thermally insulated panel can actively help not just to reduce the house temperature but also reduce the energy cost annually. Thermal insulation are materials or composites of various materials that can be bound chemically or mechanically to reduce the flow of heat through the material. However, the usually used material in the making of thermal insulated panel are too expensive, thus making the price of the product also expensive. So since most of people cannot afford to buy it, since Malaysia is one of the biggest palm oil producer in the world, the utilization of palm oil fiber may help in reducing the cost of thermal insulated panel. Next one is the problem statement. As we can know, Malaysia is a hot and humid climate all year long because of its location in the Earth equator. Based on the annual report released by Malaysia Meteorology Department in 2019, the Northern Peninsula of Malaysia has recorded 2 episodes of heat wave from 5th until 8th March 2019, with the highest record of 14.1 degrees Celsius in Chupeng, Perak. This continued with the increasing demand for air conditioning, thus led to increases in energy usage per house. By the starting of 2020, when the global pandemic is spreading all around the world, the Malaysia government take action by enforcing movement control order since 18 March 2020, and once again Tenaga Nasional Berhad TNB released a press statement saying that energy usage surged around 20 to 50% in residential area. To overcome this problem, the usage of thermal insulated panel need to be applied to residential house as soon as possible. However, the commonly used material in the industry, such as polyurethane foam, stone wool, expanded polystyrene, and extruded polystyrene, is so expensive for most Malaysians, especially those from B40 group. Thus, palm oil fiber may be one of the options to substitute the materials for thermal insulated panel. This can reduce the manufacturing costs, and as a result, the cost for buy the thermal insulated panel is also can be reduced. This study can said to be significant since it investigate the application of palm oil fiber as a thermal insulating material for roof ceiling panel. The main objective to these studies are: the first one is to investigate the mechanical properties of palm oil fiber as an insulated material for thermal insulated roof ceiling panel, and the second one is to determine the optimum content of palm oil fiber to be used as thermal insulated ceiling panel. Now we will look into the literature review for this study. First one is palm oil fiber. Malaysia is one of the world's leading producer of palm oil and seeing rapid growth in new plantation and palm oil mills through various firms, both government and private firms. Every year, the waste byproduct of the palm oil production process is increased. Only 10% of the total biomass in the palm oil mill is palm oil, while the other 90% is wasted as trash. Palm oil fiber can be found from the extraction from the front, the trunk, the empty fruit bunch, and the mesocap of the palm oil. Palm oil fiber is a lignocellulosic biomass containing lignin, hemicellulose, cellulose, holocellulose, and other chemical substance that can be in the chemical composition of the fiber. Before the fiber can be used, the fiber need to undergo a pre-treatment to remove its residual oil. This is to enhance the fiber characteristic and reduce delamination during the panel consolidation. Okay, the second one is oil palm empty fruit bunch, or OPEFB. Oil palm empty fruit bunch is a solid residue from the fresh fruit bunch, as you can see in figure A. Okay, each year, palm oil mill approximately produce about 22 to 23 millions of tons of OPEFB. In figure B, you can see the arrangement of the fiber through a cross-section sketch of a fresh fruit bunch. Okay, since the OPEFB fiber offering a great advantage in polymer composite, it is chosen to be used in this study as an additive in the making of thermal insulated ceiling roof panel. The physical and mechanical property of oil palm empty fruit bunch fiber is as we can see in the table. OPEFB contain about 73% of fiber which can be obtained from retting process. The diameter of the fiber varies from each previous study from 150 micrometer to 720 micrometer, with density the same from 0.7 gram per centimeter cube to 1.55 gram per centimeter cube. Next one is the chemical composition of the fiber is as you can see tabulated from previous studies. The fiber are known to contain chemicals like lignin, cellulose, hemicellulose, holocellulose, and ash, as you can see in the table below. The third one is gypsum. Gypsum is a soft white sulfate mineral usually mined and is a key component in the making of chalk, plaster, blackboard, and drywall. It got its name from Greek verb that means to cook, as gypsum is a burnt or calcinated mineral. Pure gypsum still have contaminants such as silica, clay, calcium, and magnesium carbonates, thus need to going through a partial dehydration process before can be used in construction. The figure in the slide shows that the gypsum powder that we can found in the commercial use and the raw gypsum mineral before the process. The property of gypsum is fairly soluble in water and come in various color depending on its purity. Besides that, gypsum also is a fire resistant material. The presence of water in the gypsum product contribute to its fire resistance. It also have thermal qualities that allow it to maintain a high level of indoor humidity and temperature stability. The next one is gypsum board. Because of growing interest in energy saving in construction for engineering application, gypsum board panel is now frequently employed in new buildings as ceilings and interior wall covering. Typically, a gypsum board has a paper sheet lining added to both of its face or wood particles or fiber, and using gypsum as the additive. Each gypsum board are different in name and based on their own function as tabulated in the table below. Gypsum board is usually utilized as a sheet material liner in lightweight structure such as LSF like steel framing and LTF like timber framing. For the usage of gypsum ceiling board, there are two main types of ceiling grid, which is exposed ceiling grid panel and concealed ceiling grid panel. Exposed ceiling panel is where the ceiling grid is visible and into the which panel are laid. Meanwhile, the concealed ceiling is a system where a panel are installed, the grid cannot be visible. The next is the one that will be in this study, which is fiber reinforced gypsum ceiling panel. The panel will be produced using the mixture of gypsum powder, OPEFB fiber and water. The property for this panel are, first one, the thermal properties of the panel. Because the building contains a cavity that may be filled with necessary quantity of insulation, gypsum ceiling panel can provide outstanding thermal performance. Interior panel protect the insulating material and in conjunction help to prevent indoor humidity from entering or being trapped in the insulation material. It also have heat storing capability, which allow a little amount of heat to be stored and reflect back later when the temperature drop. The second one is water absorption. A typical gypsum product are so quick in absorbing water, then will lose its significant amount of strength. By adding OPEFB into the mixing of the panel, it will incorporate with gypsum panel to improve the water resistance. Next, we go to the methodology. As you can see, this is the flow chart for this study. Okay, next is the material to be prepared. The first one is palm oil fiber. The palm oil fiber will be obtained from palm oil mill in Bandar Tenggara, Johor, and only fiber from empty fruit bunch is used in the study. The next one is gypsum powder. It is ready to use and do not need sand to mix in the preparation of the gypsum, and it has setting time of 25 to 30 minutes. The design of the gypsum OPEFB mixture in the making of the ceiling panel are shown in the table. We set 3 samples with 1 control. Each sample containing POF of 25%, 50% and 75% in accordance to weight of the gypsum. The test done to the ceiling panel is, first one is guarded hot plate test. Okay, the sample will be put into the apparatus and clamped between 2 heating plates. An electric heater with a set heat are generated to flow inside the guarded head hot plate device, and the heating and cooling plates will have a stable temperature once a steady condition is established. The thermal conductivity can be calculated using the equation below, where lambda is thermal conductivity, flux is heat flow rate that travel, and A is area of specimen, and E is thickness of the specimen. Next one is the core and edge hardness test. It is used to determine the hardness of gypsum panel product in accordance to ASTM C 473. It is measured by measuring the force necessary to press a steel punch into the test region. Last one is water absorption test. Water absorption tests were carried out in accordance to ASTM D 1037, which investigate the material weight differential before and after immersion in water after 2 and 22 hours. The percentage of water absorption can be calculated using the equation below. Last is the expected result. The thermal conductivity of the roof panel will decrease significantly with the amount of fiber added in the mixture, as the thermal property of the fiber is rich in cellulose, which is a good thermal insulator, and the panel can absorb less water significant with the amount of fiber added in the mixture during the test according to ASTM D 1037. That's all from me. Thank you.